Hello, good afternoon, students. So yesterday we have finished till question number 6. So now today I'm starting from question number 7. Same exercise 7.3, question number 7, approximation. Find the approximate value of f of 3.02, where fx equals to this. Here already fx is given to us, so we don't have to identify which kind of function it is. Okay, it is a polynomial function already given to us. So here we have already identified the function. It is already given as fx equals to this. So we start from the second step. The second step was to determine or to find the perfect x, isn't it? We need to find f of 3.02. So near to 3.02, which is the value? The value is 3. So that is going to be the perfect x. That is 3. And the remaining one, what will add? And I'll get 3.02. 0.02. That is going to be delta x. X is 3. Delta x is 0.02. Okay. And the sum of x plus delta x will be 3.02. Okay, so now we move to step number 3, which is very important step to find the value for delta y. So delta y, the formula is this. Put the value x, delta x, and fx, x is 3. Okay, so delta y is equals to f of 3.02 minus f of 3. And f of 3, we'll put the value for x equals to 3 out here and find the value for f of 3. So f of 3 will be 3 into 3 square plus 5 into 3 plus 3. Okay, so this page is done. Pause the video to note down. And now delta y is equals to f of 3.02 minus, this is we are calculating the value for f of 3. So on calculation you will get f of 3 as 45 minus 45, take it to the left hand side, it will be plus 45. So f of 3.02 will be delta y plus 45, delta y plus 45. We just have to calculate the value for delta y again in the same way. Delta y equals to dy by dx into delta x, which is 6x plus 5 into delta x. Put the value for x equals to 3. Delta x is already known, 0.02 multiplied, you will get delta y. Okay, so delta y we found it out. Let's put the value for delta y in equation number 1. Delta y equals to 0.46 plus 45, so hence the final answer will be 45.46, which is the value for f of 3.02. So pause the video to note down. Question number 7 part 2 is same as question number 7 part 1. Given fx is this, find the value for this by approximation. So hence here it's already identified. Put the perfect x, put the value for perfect x, x as 5 and delta x as 0.001. Start with delta y, put the values, we get equation number 1. Equation number 1 is f of 5.001 as delta y plus f5. The calculation of f5 is out here, you'll get minus 35, and calculation of delta y, this delta y is here. So on calculation you'll be getting 5 into 0.001, that is 0.005. The value for delta y, put it in equation number 1, put the value for delta y and f of 5 in equation number 1, we get the final answer. Okay, so pause the video to note down. Okay, so let's move to question number 8 now. So in question number 8, the radius of a circle increases from 5 to 5.1 centimeter. Find the increase in area. So we need to find the increase in area. Okay, we know area of a circle is given by a equals to pi r square. So we need to find increase in area. So let's see the solution. R be the radius of the circle and E be the area. So according to the question, the radius changes from 5 to 5.1. What does it mean? Previously it was 5, so R was 5, and then now it is 5.1. So what is the value for delta R? 0.01. So what is the increased value of R? 0.01. 0.1, not 0.01, 0.1 only. R is 5 and delta R, increased R is 0.1. So final, R is 5.1. That is R plus delta R. Okay, so we got the value for R. We also got the value for delta R. Here with this, don't get confused. R is 5 and delta R is 0.1, and the final R is 5.1. Okay, now we need to find the increase in area. So increase in area means delta A. We need to find delta A. The formula to find delta A is dA by dr into delta R. Differentiate your function A with respect to R, so you get dA by dr as 2 pi R. So put the value for this dA by dr 2 pi R out here in equation number 1. So equation number 1 becomes delta A equals to 2 pi R into delta R. What is the value for R? 5. And what is the value for delta R? 0.1. Putting these values in equation number 1, 2 pi r, put the value for r, and delta r is this. So on doing all the calculation, you will be getting delta A as 2 pi, r is 5, and this is delta r. Calculation is done out here. 10 gets cancelled out, so it will be pi centimeter square. So pause the video to note it down. Now question number 9 is also similar type of question. The radius shrinks from 10 to 9.8 centimeter. The radius of the spherical balloon, a sphere is given to us. So we need to find the approximate change in volume and surface area. So for that we should know the formula for volume of sphere, that is 4 by 3 pi r cube. Surface area of sphere 4 pi r square. Note down the formulas. Okay. The radius, it was 10 and now it is 9.8. So then what is the value for delta r? What is the reduced value? Minus 0.2. If you subtract minus 0.2 from 10, you get 9.8. So r is 10, delta r is this. These are the formulas for volume and surface area of sphere. So then we can easily find approximate decrease in volume, delta v, dv by dr into delta r. Put the values, you'll get this. But in your answer, if you see your answer, it is only 80 pi centimeter cube. Minus sign indicates that there is a decrease in volume, but the actual answer is this. Okay, even if you write this or this, it doesn't matter, but minus sign just indicates that there is a decrease in the value. Similarly, S, approximate change in delta S, that is surface area. So put the formula, differentiate S and put the value for r and delta r, you get the value. Okay, so pause the video to note down. This was question number 8. Okay, so next we move to question number 10. That was question number 9, now is question number 10. Okay, in question number 10, it is the ISC 2018 question, 2 marks. Okay, read the question. Find the approximate change in the volume of a cube of side x meter caused by decreasing the side by 1 meter. 1%. Find the approximate change in the volume of a cube. So we need to find delta V. Okay, so volume of a cube, the formula is x cube, that is side cube. Okay, so we need to find delta V using the formula delta V equals to dV by dx into delta x. Now dV by dx, you can simply find it out by differentiating with respect to x, that is 3x square into delta x. Now we need to find the value for delta x. Okay, so now if you read the question, the approximate change in the volume of a cube of side x meter caused by decreasing the side by 1%, decreasing the side by 1%. So initially here we need to find delta x now. Okay, in equation number 1, so initial value for x was initial side was x, and now finally it is now been decreased. Now final value for x will be x minus 1% of x, which means there is a decrease in the side by 1%, isn't it? So when it's decreased, you have to minus it. So x minus 1 by 100 of x, so which is 99x by 100. So this is the final value, and this is initial value. You can also write this 99x by 100 as this is x plus delta x, isn't it or not? Okay, so I need to find the value for delta x. I need to find the value for delta x. The value to find the value for delta x will be delta x is final minus initial. Final minus initial. So final is 99x by 100. Initial is x. So if you do a calculation, then you will be getting minus x by 100, that is minus 0.01. So this is the value for delta x. Put the value for delta x out here, then you will be getting the actual change in the volume, that is delta V. So putting the value for delta x in equation number 1, you get 3x squared into this, which is minus 0.03 x cube. So in your answer you'll just be getting positive 0.03. Minus sign means there's a decrease in the volume. Okay, and in the same way question number 10 part 2 is also done out here. So pause the video to note down, and then you can understand as well. Surface area now. So S 6x square, we need to find delta S. approximate change in the surface area. Okay, delta is the formula is ds by dx into delta x. So the formula is 6x squared, so differentiate will get 12x into delta x. Now here the side is increased now. Okay, so initial side was x, the final side will be x plus 1% of delta x, that is this. So delta x will be final minus initial, you'll get this, and put this value out here, you get the final answer. Okay, so your assignments for today will be question number 7 part 2, question number 11 part 1, and 11 part 2. Number 7 part 2 is already there in the video, yesterday's video which I have sent. Okay, so you can refer to that, and question number 11 part 1 and 11 part 2 will be your homework as well. So tomorrow we'll start a new topic as well as new exercise. Okay, so thank you.